This asteroid alert vanished for the best possible reason. The asteroid did not disappear. Its risk corridor did. Earlier in July, the European Space Agency's Near-Earth Object newsletter described 2026 MT1 as its most interesting new risk list entry. Across possible dates in 2052 and 21-2 orbited, the modeled probability added up to roughly 1 in 120,000. But on July 20th, NASA's Sentry system moved the object to its removed list. The recorded reason: every previously detected potential impact had been eliminated. A risk list is not a prediction that an impact will happen. It records orbit solutions that still fit the measurements available at that moment. So, what did astronomers actually see? Not a detailed space rock hanging over Earth. They saw a faint moving point. NASA's current small body record uses 91 observations across a 39-day arc. Its absolute magnitude is an estimate derived from brightness, not a direct measurement of a known shape. The object was classed as an Apollo asteroid, meaning its orbit can cross Earth's path around the Sun. That tells scientists where an orbit goes. It does not mean Earth and the asteroid reach the crossing point together. Here is where the apparent contradiction begins. A new asteroid may be observed over only a short arc. Each image supplies a position against background stars, links several positions, and computers calculate a family of orbits that fit. But tiny measurement differences spread outward over decades. Some allowed paths may pass near Earth. A much smaller subset may intersect it. Would you rather the system publish a 1 in 120,000 possibility early, or hide it until every uncertainty is gone? That trade-off is why transparent risk tables can look more alarming than the evidence is. New observations collapse the uncertainty. Survey telescopes discover moving points. Follow-up observatories measure them again from different places and times. The Minor Planet Center collects those observations. NASA's Center for Near-Earth Object Studies calculates high-precision orbits and checks future encounters. The quality of each point matters. ESA's July update described tools that examine measurement residuals, the tiny gaps between where an orbit predicts an object should appear and where a telescope records it. Repeated bias can reveal a timing problem, catalog issue, or outlier. Correcting those effects can shift a cloud of possible future positions. For 2026 MT1, that cloud changed enough that Sentry removed all potential impacts it had previously detected. NASA timestamps the removal at July 20th, 1339 UTC. The asteroid still exists. Its Apollo classification still describes its route around the Sun. What disappeared was the set of current observation-fitting paths that struck Earth. Removed does not mean scientists proved a philosophical zero chance for all time. It means the specific potential impacts identified by the monitoring system were eliminated using the available observations. Materially new data could trigger another assessment. The early ESA snapshot and later NASA record are not rival stories. They are two frames from one process. One shows uncertainty being published. The other shows uncertainty being reduced. This is planetary defense before rockets or emergency plans. Telescopes, timestamps, shared observations, residual checks, and software willing to update a public answer. The reassuring part is not that a warning can appear. It is that evidence can make it disappear.